So we had completed alkane, right?
Yes.
Wait a minute, let me tell it. Okay. Write a topic. That is alkene. So here is alkene and its general formula is CnH twin, right?
Yes.
The number of hydrogen will be equal to the double the number of carbon. If we are taking C2, the number of hydrogen will be C4. If you are going to take the number of hydrogen as C3, the number of hydrogen will be 6. This C2H4 is known as ethene and its smallest alkene. It's the smallest alkene, and the molecular mass of the smallest alkene is basically 28 U or 28 gram. Gram stands for 1 mole, and this is for 1 atom of 1 molecule. This is for basically 1 molecule. Is that clear?
Yes.
Now, moving to the alkene and its structure. If we are talking about ethene, then its structure will be like this. Do you know how to do hybridization? What will be the hybridization of this carbon? What will be the hybridization of this carbon? Sp.
sp2.
So basically, in organic chemistry, it's very easy to calculate hybridization. Okay, to find hybridization equals to basically sigma bond plus lone pair. So if we are going to calculate hybridization, carbon doesn't have any lone pair, so it will be 0. If you are going to calculate sigma bond, then this is sigma, this is sigma, this is sigma, so it will be 3. 0 plus 3 will be equal to 3, and whenever it will be 3, it will be equal to sp2. So if this sum is equals to 2, that means hybridization equals to sp. If this sum equals to 3, that means sp2, and if this sum will be equal to 4, that is sp3. In case of carbon or organic chemistry, and if we are talking about hybridization of carbon, then this will be the maximum. And in case of inorganic chemistry like SF6, inorganic chemistry, the compounds like SF6, PCl5, then where you will get the value of this sum will be equal to 5, 6, 7. And if you get 5, then the hybridization will be sp3d. And if you will get 6, that will be sp3d2. And if 7, that will be sp3d3. Is that clear?
Yes.
So in this case, sp has a structure or geometry that is linear. sp2 is basically trigonal planar. This is planar, trigonal, planar. And if you are going for sp3, that is tetrahedral, and so on. Okay. So this will be the geometry of ethene and all. Do we have a class of 1.5 hours or 1 hour?
1.5.
Okay. Can I change the slide?
Yes.
Okay. So here is the basically geometry of ethene. Now we are going for nomenclature. There is a topic in alkane, that is conformation, that we will study in the end of this chapter. Okay.
Okay.
Just don't think that I just skipped it. We will study it in the end of this chapter. So Nomenclature. You already know about the nomenclature, so I'm going to give you some questions. Just tell me the nomenclature, IUPAC nomenclature.
1, 3, 5,
1, 3, 5,
7 tetradiene,
tetra,
tetra, octane.
Is this your answer?
Yes, octane.
Oh. So 1, 2, 3, 4, 5, 6, 7, 8. So you can also write basically 1, 3, 5, 7 octa tetra e, or you can write octa 1, 3, 5, 7 tetraene. Is that clear?
Yes,
So you can also find the number of sigma bond or pi bond.
yes.
Can you calculate the number of sigma bond as well as number of pi bond in this?
4 pi bonds.
That's very good. 4 pi bonds. And what about sigma bond? Can you calculate sigma bond?
Six.
Not only 6. If it is, if you are thinking that C double bonds, carbon always make 4 bond. And if it doesn't look 4, then that means hydrogen is attached to it, and hydrogen doesn't need to. So basically, if you I'm going to write its complete structure formula, it will be like C double bond, single bond, C double bond, C, single bond, C double bond, C. How many number of carbon I just wrote, and now C double bond C, right? Now in this carbon is making only 2 bonds, that means 2 hydrogen are here. This carbon making 3 bonds, that means 1 hydrogen is here, 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 and this making only 2, so that means this. Now going to count the number of sigma bond: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So number of sigma bond is 17. Is that clear?
Yes.
Thank you. Can I change the slide?
Yes.
So now I'm going to give you another question for IUPAC nomenclature, and you have to name it as well as find the number of sigma bond as well as pi bond. So the question is like CH2 double bond C, and here CH2, CH2, and CH3 whole twice. So you have to give IUPAC name, sigma bonds, how many sigma bonds are here, and how many pi bonds are here. Can you do it, or should I explain it?
Is it hept 4-ene?
What you just said? Is it
Hept 4-ene.
Hept 4-ene? No, it's not Hept 4-ene. First, I'm going to, whenever the question will be like this, and if you have to solve the IUPAC nomenclature, just don't do it like this. You just need to open it so the answer will be correct, because it will be more clear to name the IUPAC of this molecule or compound. You can see here it is twice. That means CH2, CH2, CH3, first time, and second time CH2, CH2, CH3. Now can you name this?
It's still heptane, right?
Heptane. Just numbering it first: 1, 2, 3, 4, 5. Wherever you go, if you want to come down from here, 3, 4, it won't change. Now name this. You can see there is a branch at you can see there is a branch at number of carbon, at second number of carbon. At second number of carbon, you can see a branch. What does this branch is? Basically 3 carbon, that is prop. And if it is using, if you are going to use at branch, it will be propyl. So the name will be 2-propyl. And then come to the parent chain, it will be pent. And on the first carbon, it is double bond, so it will be pentene, or if you want to write it, pent 1-ene. Right? Is this clear, Akifah? Now name the what? How many number of sigma bond as well as number of pi bond? Tell me.
"21 sigma bonds, 1 pi bond."
Only 21 sigma bonds. Check it out.
"23
23 sigma bonds
1 pi bond."
and 1 pi bond. You can see only 1 pi bond is here. So there it is. Can I change the slide?
Yes.
Have you studied the part isomerism in general organic chemistry, the basic of organic chemistry?
Yes.
So you have heard about cis and trans as well?
Yes.
Okay. So I'm going to give you some questions regarding this. Basically, this geometrical isomerism, and here there are two types of geometrical isomerism. One is cis and another is trans. One is cis and another is trans, and this is arises due to restricted rotation along double bond. So how it is? Basically C double bond C H Cl HCl. Just make sure if one carbon has same group, that molecule or compound won't show, that molecule or compound will not show geometrical isomerism. If I'm going to give you like CHH, and here it is bromine and iodine. First, if the question asks whether it shows geometrical isomerism or not, you will go for, and you will go and check it that this carbon has same group. That means no GI. If it doesn't show any geometrical isomerism. If you are going for this, now first check on each carbon that the group should not be same. You can see hydrogen and chlorine on the same carbon. You have to check on the same carbon. Don't compare it from this carbon to this carbon. Okay, are you getting my point, Akifah?
Yes.
And if this happens, like this carbon doesn't have any same group and this carbon too, so if the same group on the same side, this will be cis, and if the same group on opposite side, this will show trans. Is this clear?
Yes.
Okay, just write it, and I'm going to give you some questions then. If you are done with this, let me know.
Done.
Very good. So we are going to have some questions on cis or trans. When will your be paper? Annual exams?
And starts from 17th March.
17th March, right? Draw cis and trans. Isomers of the following compounds. Also write there IUPAC names. CHCl double bond, CHCl. Cis and trans we need to find. C2H5, CH3. Double bond. Wait a minute, Akifah. Is the screen visible to you? Akifah, is the screen visible?
Yes.
Okay. You have to write the cis and trans of this as well as second.
Done.
Done. So just make sure you have done correctly. It will be cis, like cis, and this will be trans, like, right?
Yes.
What will be the nomenclature?
Um.
You can see 1, 2. So here it will be 1,2 dichloro ethane, sorry, eth one in or ethene. or in the most of in books it will be written like cis 1 comma 2 dichloroethene. That represent this representation, the compound is in the form of cis. Is that clear?
Yes.
1 2, and it will be like trans. You can write 1 comma 2 dichloro eth 1 in, that also means ethene. Is this clear?
Yes.
What about this? Have you done this part too?
Yes.
Okay. So it will be like C double bond C, and here it will be CH3, and here it will be C2H5. Again, here it will be C2H5, and here it will be CH3. So this will be cis because same group on the same side. So it is cis, and same group in opposite side. Same group on opposite side, it will be trans. It will be trans. So can you name it, this or this?
1 comma 2.
1 comma 2. So this is wrong. If you are going to 1 comma 2, it's wrong. Just think about the nomenclature and do it again, please. Should I name it?
Yes.
You can see. You can name numbering from this side, but it will be wrong. We always go for lengthy chain. Okay, so I'm going to write its complete structure formula. It will be like CH3, C double bond C, and CH3. And now I'm going to write this as CH2CH3. Can I write this? C2H5 as CH2CH3. In the same way, CH2CH3. Now I can 1 2 3, I can number it like 1 2 3 4 5 6. So double bond is covered, as well as the longest chain from this compound is covered. So the name will be 3 comma 4 dimethyl hex 3 ene. And if it is if we are going to name this cis 3 comma 4, and if you are going to name this trans 3 comma 4.
Okay.
Okay. If you're done with this, let me know.
Done.
Okay. So here it is. Now we are having a topic, that is preparation of alkene. Preparation of alkene. Again, for the first, from alkynes. So we are going to prepare alkene from alkynes. So just taking an example, RC triple bond CR dash. This R represents alkyl group. Alkyl group, you already know that methyl, ethyl, propyl, butyl, it can be, right?
Yes.
Now, when we treat alkyne with H2 in the presence of palladium and carbon, this reaction is basically addition reaction. And it is known as hydrogenation. This is known as hydrogenation. That means hydrogenation means addition of hydrogen. And you know that carbon makes only 4 bond, and here carbon is with 4 bond. And if you are going to add this H2 in this compound, that means previous in the previous compound that has already 4 bonds with carbon, it will be broken. So it will be R C double bond C R dash, and hydrogen will be inserted in this like H and H. So you can see this is alkene, right? So we prepare alkyne, we prepare alkene from alkyne in this way. If you are going for CH triple bond CH and you are going to add H2 in the presence of palladium / carbon, so it will be like this will be adding, so a bond will break down, it will be CH double bond CH, and hydrogen will be added on both carbon with equal amount. So one hydrogen will be attached with this and one hydrogen it will be attached with this, so it will be CH2 and CH2. So this is basically ethine and this is ethene. Is this clear?
Yes.
Okay, just write it.
Done.
Very good. Now we can also use like CH3 C triple bond CH. This is alkyne, and you are if you are going to add H2, you can use another reagent that is known as, that is basically sodium / liquid NH3. Sodium / liquid NH3. Either you use palladium / carbon, or either you use sodium / liquid NH3. It will do the same. Like this H2 will be added up into this, so it will be the bond will be broke, and it will be like this, and one hydrogen will be inserted to this carbon and this. So this is basically propane, and this is basically propene. Okay.
Done.
Very good. So we are going to have another preparation from another. We are going to have preparing alkene from another method. Wait a minute. So another method is basically from alkyl halides. Second method is from alkyl halides. This is from alkyl halides. How we prepare basically alkyl halides. So I'm going to write some notes regarding this. Just write with me. Alkyl halides, that means Rx. R represent alkyl and X represent halogen, that is halide. On heating with alcoholic potassium. Wait a minute. Just write alcoholic potass. And what potass means, I'm going to write it and I'm going to explain it. Basically, potass is potassium hydroxide. Potassium hydroxide dissolved in alcohol. This is basically potass. And alcohol, just say ethanol. Ethanol, do you know what is ethanol? This is a alcohol. It is alcohol, ethanol. Just say ethanol. So basically what happens when we heat alkyl halide in the presence of alcoholic potass, that means potassium hydroxide in the presence of alcohol, it eliminates that means removed out, eliminate one molecule of halogen atom, one molecule of halogen atom, and just don't write halogen atom, halogen acid, one molecule of halogen acid to form alkenes, to form alkenes. This reaction is known as, you can write first, write it, then I will explain. This reaction is known as dehydrohalogenase. Dehydro, this reaction is known as dehydrohalogenation and also known as beta elimination reaction, also known as beta elimination reaction. Is this clear? Just write it and let me know if you are finished.
Done.
Very good. So just see here. If you are going to take alkyl halide and what happens when we treat it with potash, that means alcoholic potassium hydroxide. So I'm going to take this X represent basically halide, halogen, and X is for chlorine, bromine and iodine, not fluorine. And if you are going to treat it alcoholic KOH, from alcoholic KOH and heat it, then what we get from here, the carbon which is attached from X, that is halogen, that carbon is known as alpha carbon. Are you getting my point? The carbon which is attached from X halogen, that carbon is known as alpha carbon, and the carbon which is attached with alpha carbon is known as beta carbon. Is this clear?
Yes.
Now what happens whenever you treat this alkyl halide with alcoholic KOH and heat it, then from alpha X will be eliminated and from beta H will be eliminated. So here is halogen acid, that is HX. Is this clear?
Yes.
And what happens here? C H H single bond, C H H. How many bonds carbon is making here? How many bonds? How many bonds do carbon have? Does carbon have here? What I want to ask is how many number of bonds that carbon is making here? How many carbons you are looking at?
2 carbons.
2 carbons. How many bonds form? 3 bond. And generally carbon makes 4 bond. So it will be, wait a minute, it just hanged. So it will be double bond. Is this clear?
Yes.
So we prepare alkene from alkyl halide like this. Now you can see it has 2 names, that is first is dehydrohalogenase. So whenever a term is like halogenation, only halogenation, that means addition of halogen. Only hydrogenation, that means addition of hydrogen. And whenever the there will be prefix like dehalogenation, that means halogen, removal of halogen. Dehydrogenation, that means removal of hydrogen. And here a term is used, that is dehydrohalogenation. Hydro stands for hydrogen and halogenation stands for chlorine, bromine, iodine. So you can see dehydrohalogenation. So we are removing hydrogen as well as X. That's why it is also known as dehydrohalogenation. Is this clear?
Yes.
Now you can see the another name of this reaction is beta elimination reaction. Beta elimination reaction, you can see it is known as beta elimination reaction because we remove hydrogen from beta carbon. Just write it. And write the rate of halogen. Iodine, bromine, and then chlorine. And the rate of alkyl group, that is 3 degree, 2 degree, 1 degree.
Done.
Very good. So can you write the product? How many products do they have?
Okay. The product is CH3, CH, CH, CH2.
Wait a minute, just name it. Never tell like this CH3, CH3, CH2.
Okay.
The product is CH3. You can just name it and let me know.
2-pentene.
Wait a minute. 2-pentene.
Yes.
So you can see only one product is possible or more than one product is possible here.
2.
Two product. So both the products are different. So there will be two name, two IUPAC. The name of another compound.
HCl.
Hex.
HCl.
HCl. Okay. What I want to say, the HCl is basically byproduct. Whenever there will be question like this, how you are going to solve it, you just solve one 2-pentene. You can see this is alpha carbon, right?
Yes.
And this is beta carbon, right?
Yes.
And this is beta carbon 2. Is this clear? What I told you is that the carbon which is attached from chlorine is called alpha carbon, and the carbon which is attached from alpha carbon is beta carbon. So there will be two beta carbon, right?
Yes.
Now concentrate here. You will get when the number of alpha carbon, the alpha carbon, I'm going to just show you the CH3. Now can I write this as this? Can I write this?
Yes.
Now I'm going to remove this. If I'm going to remove this H and Cl, the double bond will be the double bond will be here. So CH3 CH double bond CH, and it will be CH2 and CH3. Is this correct?
Yes.
Now I can also remove the double hydrogen. I can also remove the hydrogen from here too, right? So if I'm going to remove this, the double bond will be CH3 and this will be CH2 because I'm not removing it, and it will be CH and then double bond and then CH and then CH3. Are you getting my point?
Yes.
Now name it. from this side, the double bond will be far away. So I'm going to number it from this side, and the name will be like pent 2-ene. You also said that 2-pentene, right?
Yes.
Now, if you are going to number it from here, it will be far away as compared to the opposite direction. So basically 1, 2, 3, 4, 5, pent 2-ene, it will also be. So since the nomenclature is same, that means both are identical compounds. Both are identical compounds. So the product will be only one. But make sure you are going to check every beta carbon, and if beta carbon has hydrogen, you will remove it and make a product and then name it. If the name will be different, the compound is different, that means that that is also a product. If the name will be same, that means identical products, that means one product. And don't go for HCl. HCl is just a byproduct.
Okay.
Are you getting my point? It's just a coincidence that this has only one product. Okay.
Okay.
So can you write the product of the second?
Pent 2-ene.
Pent 2-ene. Only one product is possible or more than one product?
More than one.
Yeah, pent 2-ene, I don't think so. Just I'm going
4-methyl pent 2-ene.
okay, just see, this is alpha carbon, right?
Yes.
This is beta carbon and this is beta carbon. If there is beta carbon and beta hydrogen, if there is beta carbon and beta carbon has hydrogen, that is known as beta hydrogen, then I'm going to make a product like you can see, this is X, right? And I'm going to take the left one first. So it will have hydrogen. I only need one hydrogen, that's why I'm taking hydrogen. And you can see alcoholic KOH. So I'm going to remove this, so the product will be like this, right?
Yes.
And this also have hydrogen, so if you are going to remove this, the product will be like this. So there are two products. The one is, you told me the correct answer, 4-methyl
Pent 2-ene.
pent 2-ene, and the another is, you can see 1, 2, 3, 4, 5. So it will be 2-methyl pent 2-ene. Is this correct?
Yes.
Okay. So can we move to the next preparation?
Yes.
Okay, moving to the next preparation, that is from vicinal dihalide. There are two terms in organic chemistry which is similar. Basically, one is vicinal dihalide, vicinal, and another is gem dihalide. Di that represents 2 and di that represents 2. What is vicinal dihalide? When halogen is present on adjacent carbon. When halogen is present on adjacent carbon, this is vicinal dihalide. And when hydrogen is present, when halogen is present on the same carbon, this is gem dihalide. Are you getting my point? Is this clear?
Yes.
When halogen is present on adjacent carbon, that is known as vicinal dihalide, and when halogen is present on the same carbon, it is gem dihalide. So what happens from how we prepare vicinal dihalide from how we prepare alkene from vicinal dihalide? Basically, this is dehalogenation. This reaction is known as dehalogenation. So I'm going to write a point. Write with me. Dihalides in which two atoms are attached. I'm going to write the definition of vicinal dihalide. Two atoms are attached to two adjacent carbon, two adjacent carbon atoms are known as vicinal dihalide. You can also write the definition of gem dihalide. Dihalides in which two atoms are attached on the same carbon atom are known as vicinal dihalide. This is the definition of vicinal dihalide. Now, how we prepare? Basically, vicinal dihalides on treatment with zinc. Vicinal dihalide on treatment with zinc metal. On treatment with zinc metal, lose a molecule of ZnX2. Whenever we treat vicinal dihalide with zinc, zinc will take the dihalides, and it will be removed from the molecule. Lose a molecule ZnX2 to form an alkene. This reaction is known as dehalogenation. This reaction is known as dehalogenation. Is this clear?
Yes.
Okay, just write it and let me know if you're done with this.
Done.
Done. Very good. Now, I'm going to show you the reaction. So basically, if there is CH2Br and CH2Br, you can see both the bromine present on adjacent carbon. And if you are going to treat with Zn, that means you can see this bromine and this bromine, both bromine will be together, and it will be with zinc, and it will lose one molecule of ZnBr2, and what will form CH2 double bond CH2 will be formed. If you want to see, you can see like this: CH, this is Br, this is Br. You can also see this is Br, this is H, and this is H. And if you are going to treat with Zn, this Zn will take Br, and it will be outside by byproduct. Now you can see CH single bond, H, this is single bond H, and 2, this will be double bond. Is this clear?
Yes.
Now CH3 CHBr CH2 Br plus Zn. Write the name of the product. Are you done with this?
Yes.
So what will be the product? The product will be CH3 CH double bond CH2, right?
Yes.
This ZnBr2 is the byproduct. Here you can name it as propene E or propene prop 1E. Is this clear?
Yes.
Can I change the slide?
1 minute. Done.
Very good. Now, fourth is from alcohols by acidic dehydration. From alcohols, we are going to prepare dihydrogen by acidic dehydration. So basically, what is acidic dehydration? I'm going to write the reaction first, like the alkyl halide. You can see it. This has the same mechanism as alkyl halide. So in alcohol, we are going to use concentrated H2SO4, which is also known as dehydrating reagent. Dehydrating reagent, that means it will remove water molecule. Dehydrating reagent. Like in alkyl halide, that was alcoholic KOH, and we heat it, then we got alkene. In the same way, we use concentrated H2SO4 in alcohol and heat it, then we will get alkene. This OH is attached with this carbon, that means this carbon is alpha carbon. In the same way, this carbon will be beta carbon, and beta carbon has three hydrogen. Is this clear?
Yes.
Now you can see this has three hydrogen. So one of the hydrogen will be used in making or preparing alkene. So this will be removed and it will be like C double bond C, and this is H, 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 and H. So this will be ethene, and here it is ethanol. This reaction is known as basically dehydration of alcohol, acidic dehydration. Acidic dehydration of alcohols. And you can see OH and H together will form H2O. And what I just said is that concentrated H2SO4 is dehydrating reagent. That means it will remove one molecule of water, and you will see, you are seeing that this is H2O that is coming from this ethanol, this alcohol. So please do it and let me know if you're done with this.
Hello.
Yes. Yes, Akifah, are you done?
Yes, it got disconnected.
What you just said?
It got disconnected.
Okay. So are you done with this?
No, 1 second.
Okay, take your time.
Done.
Done. Now going to give you some questions. It will be solved in the same way that you did for alkyl halide in the presence of alcoholic KOH and heat. Okay, so are you done with this?
No.
Okay. Should I help you?
Mm.
Yes.
1 minute.
Okay, okay. Take your time. Go for alpha hydrogen, alpha carbon, beta carbon. Then go for beta hydrogen.
Can you help?
Yes. You can see. If you are going for this is alpha carbon, this is beta carbon, this is beta carbon, and this is also beta carbon, right?
Yes.
So if you are going to remove this OH and from this hydrogen from this carbon, the double bond will be like this, and others will be like they are earlier. Is this clear?
Yes.
Now, if I'm going to remove hydrogen from here, OH will be removed from only alpha carbon. So the double bond will be like this. Yes or no?
Yes.
Are you getting my point? If you have any doubt regarding this, just ask me. Now going to remove hydrogen from here, and you can see this was like this, and the double bond will be like this. Okay.
Okay.
Now name it. So 1, 2, 3, 4, 5. You can see 3 methyl pent 2 in, right? Going to name it 1, 2, 3, 4, 5. So the name will be 3 methyl pent 2 in. Are you getting my point?
Yes.
And this both have same name. That means identical compound. That means identical compound. That means only one product is formed. Are you getting my point?
Yes.
Now I'm going to name it 1, 2. Wait a minute. Sorry. This I abruptly closed all the time. Now 1, 2, 3, 4, and here is a branch. So the name will be 2-ethyl butene. So this has different name. That means different product. So from this reaction or reactant, we have only 2 products.
Okay.
Okay. Can you solve it?
Yes. 2,4 methyl 2 pent methyl.
How many products does this reactant have?
2 identical.
Two identical, that means only one product. You can see it will be like this, or the another will be like this, right? And both are same, identical, so only one product. Okay, can we move to the next part? No.
Yes.
Now, chemical properties. Just write physical properties first. Physical properties of alkene. Basically, we are studying alkene, that is understood, that's why I didn't read of alkene. Okay. Wait a minute, please. The first three alkene. The first three alkenes are gases. Next 14 are liquid. And the higher ones are solid. Higher one, that represents basically they will have more molecular weight, and basically molecular weight directly proportional to van der Waals force of attraction, and if there will be more molecular weight, van der Waals force of attraction will be more, and the higher ones will be in solid state. Is this clear?
Yes.
Okay, just write it. And if I'm going to ask you which has more boiling point, the one with more surface area or the one with higher molecular weight? Okay.
Yes.
Okay, just write it and let me know, then we will move to the chemical properties.
Done.
Done. Thank you. So just write a topic, chemical properties. So this is basically chemical properties of alkenes. Chemical properties of alkenes. The first one is addition of dihydrogen. So what we do in chemical properties, basically we react alkene with different molecules, compounds, and see what happens. Addition of dihydrogen. So you already know what is going to be happened. CH2 double bond CH2. If you are going to add dihydrogen in the presence of nickel, palladium, and platinum, just let me know the product. What will be the product?
Alkene.
Name of the compound.
Ethane.
What you just said? Ethane. Basically, we need to do addition of hydrogen, that is hydrogenation. So one of the bond will break and one hydrogen will be attached with each carbon, then it will be ethane. Okay. Is this okay with you?
Yes.
Okay. Let me know the name of the product.
Butane.
Butane. Very good. The name of the product will be butane. Can I change the slide?
Yes.
The next properties, chemical properties, is basically addition of halogens. Addition of halogens. We are going to add halogen, and how we are going to do it? Just focus on the board. CH2 double bond CH2, and whenever we want to add halogens, that is Br2, Cl2 or I2, we need CCl4. It will be added in the presence of CCl4, carbon tetrachloride. And how it will be added, this is very important. Like hydrogen, if you are going to add this, carbon already has 4 bonds, so one of the bonds should be broken, so it will be CH2, single bond CH2, and one bromine will go to the one of the carbon, and one bromine will go to the one of the carbon along the double bond, and the product will be this. It's very easy. The chemical properties of alkene is very easy. Akifah, can you send the deleted syllabus and all the syllabus of second term annual exams to Nishkar sir?
Okay.
Okay, please send him or tell him to send me.
Okay.
Okay.
This will be dibromopentane.
Dibromo, what will be the number where dibromo exists? First, second, third, fourth. It will be like this. Bromine will be here and bromine will be here too, right?
Yes.
So it will be 1, 2, 3. So it will be 2, 3. The numbering is very important. Dibromo, because here we do not know where the bromine is bromine present, on first carbon, second carbon, or on the first carbon both bromine present, or wherever. So the numbering is very important. Is this clear?
Yes.
Now moving to the next part, that is basically addition of hydrogen halide. First look at the screen and then you will write. Okay, just let me say what I want to say. Whenever there is alkene, CH2 double bond CH2, and if you are going to add hydrogen halides, just take an example of HBr. So you know carbon is already making 4 bonds, so one of the bond will be broken and it will be like CH2 single bond CH2, and bromine will be attached to one of the carbon. Okay, basically I just took an example of symmetrical alkene. What is symmetrical alkenes? Basically, if you are going to attach bromine on any carbon, it won't change. Like if you are going to attach CH2Br bromine on the first carbon, the name will be changed or not? Yes or no? The IUPAC name or the compound will change or not? If I'm saying that the name will not change, that means the compound will not change.
Yes.
So you can see this is symmetrical alkene because it doesn't affect the position of bromine. If you want to add on the right hand side of the carbon, it will give the same product. Now going for this HBr, what will be the product? You can see the I'm going to add this, so one of the bond will be broken, so hydrogen here and bromine here. Or if you want to change its position, will it affect it? Both are same or not? Both are same. So if bromine is here, so you are going to numbering it from right hand side, and if bromine is here, you are going to numbering it from left hand side. So both are same, identical in case of symmetrical alkanes. Are you getting my point?
Yes.
Now what if there is unsymmetrical alkene? What if there is unsymmetrical alkenes? What will happen? Like if we are going for propene, like CH3 CH double bond CH2, and if you are going to add HBr, you will see this bond will break and the product will be bromine CH3, because hydrogen will go to this carbon and bromine is going to this carbon. Again, if I'm going to change the position, both are different or same? Let me know.
Different.
Different, because this is 2 bromo propane,
Yes.
and here you can see 1 bromo propane. So what I want to say is that if there is symmetrical alkenes, that won't affect the addition of hydrogen or bromine. You can add at any place along the double bond. Okay.
Okay.
But if we are talking about unsymmetrical alkene, there will be 2 rules. One of the rule is Markovnikov and another rule is anti-Markovnikov, Kharash or peroxide effect. We will talk about it later. Just write it and let me know if you are finished with this.
Can you scroll down?
Yes, why not?
Done.
Very good. Just write a topic. Addition of hydrogen halides. Wait a minute. Just write addition reaction of HBr to unsymmetrical alkenes. Unsymmetrical alkenes. So here it is, basically unsymmetrical alkenes. That is also known as, this reaction is given by, there is a rule, Markovnikov's rule. And what does this Markovnikov's rule says? We will talk about it. Going to write it. Just write with me. This rule states that negative addendum. This rule states that negative addendum part wait a minute. Negative part of the addendum. Negative part of the addendum negative part of the addendum gets attached to that carbon which has lesser number of hydrogen, and positive will go to that carbon which has more number of hydrogen. Just write it and then I will explain it.
Done.
Done.
Yes.
So if I'm asking you that this is basically an alkene, unsymmetrical alkene, and if you are going to add HBr, now tell me in HBr which atom is negative and which atom is positive. What do you think? The one with more electronegative, which is more electronegative?
Hydrogen. Bromine is electronegative.
Electronegative, more electronegative. Basically this is negative part and this is positive part. So, and now you will see along double bond which has lesser number of hydrogen, this. So bromine will go to this and hydrogen will go to this, and the product will be like this, the major product. Are you getting my point? Akifah,
Yes.
are you done with this? Any doubt?
No, I didn't hear. I got disconnected.
Okay. You just know that bromine is the negative part. Negative part will go to that carbon along a double bond which has lesser number of hydrogen, and positive will go to that carbon along double bond which has more number of hydrogen. So I just write bromine to the this carbon, attach this carbon. I just attach bromine to this carbon because it has lesser number of hydrogen. So the main product will be this. So 2-bromopropane. And if you got it understand, then try this and let me know the name. Are you picked them?
IPAC name of the
Yes.
product.
Yes.
Okay.
Yes. It's so easy.
Bromobutane.
Not bromobutane. You can see this is only C. So it has 2 hydrogen. And this carbon already made, made 3 bonds. It has 1 hydrogen. So bromine will come to the carbon which has lesser number of hydrogen. So name will be 2-bromobutane.
Okay.
Okay.